Hey guys, welcome back. Hope you are able to hear me. Let me try to adjust this. Okay, that works. Right. So, today we are gonna see an interesting topic, which is, can Nomadsculpt replace CAD designs? Might be for daily, might be for 3D prints particularly. So this is an example which I have here. I designed using Nomadsculpt, and there are a lot of features available within Nomadsculpt which can be used to design these, which might give closer, might be even better output similar to CAD. So I have this 3D printer in my hand, so you can see. I was trying to find a toothbrush stand in Maker's World, and I couldn't find the right model of my preference, and I wanted to design something which suits my case. I couldn't find one in Maker's World. To be honest, I could have just gone with whatever they had there. There were a lot of impressive designs, but might be uh, I didn't get that feel out of those designs there. Then I was thinking, okay, let's design it using some CAD software, and you know how expensive CAD tools are nowadays. The subscriptions are monthly. They go by monthly subscriptions, which I typically hate, and that is the selling point for Nomadsculpt. You pay once, and the tool is for other years. And I've been using this tool since 2022, and I thought, why not use Nomadsculpt to design this? And I used to struggle designing hard surface modeling in Nomadsculpt because it typically gives you smooth versions of it. I wanted sharp corners so that it looks crisp when I actually 3D print. So I wanted to change my mindset when I uh, thought of designing this, and yeah, eventually I found this is how I designed it. Uh, I'll go through the process how I did this, and I'll also give you uh, a tool. I do have a tool to measure the dimensions within Nomadsculpt, and if someone is interested to get it, I can, yeah, give it away during my next stream. If someone is really interested, you can put a message uh, in the stream, or might be once the video release, you can put a message. You can send you that. I'll show you what I mean. Uh, yeah, and also I'll show you how I went through the Bamboo Studio slicer to get this hexagonal pattern, honeycomb pattern here on both the sides. And that was simple technique which gave this cool visual look. And yeah, let's see how it goes. So this is a final version, and I'll show you how each and individual part of it was actually designed. So this here has all the tube features and cylinders, everything which I used for designing this. And as a basic, this is the base of the design by the whole. If you think, let me switch off this post processing. and switch on the face groups, so that, and also wireframe. Yeah, this is how the tube tool was designed initially. This is the base for the whole body, and this is the starting point of the design by itself. To get to this point, I wanted to define the dimensions what I want as a final product. So that is where the tool comes in, which is here. So this is a simple scale which I designed using 3D CAD software, and what it does is it is literally a scale on all 3 axes up to 100 centimeters, X, Y, and Z, which comes around 40 inches. And yeah, most of the commercial 3D printers which we have in the market can accommodate, like, we can accommodate within this scales. So I prefer to have a smaller version, and this should be enough for most of the cases. And I let's say if in case I bring a box within Nomadsculpt, it straight away goes to the axis in the center, and if I go it in a solo view, it's going to be there, and if I zoom it in, it's so small, we don't know what size it is. And that is where this scale comes handy. You can confidently design your models up to scale. And so for this case, since I have the scale here, I know this line here is 200 mm, this line here is 200 mm. So that means even if I hide everything here, and even this one, let's say, that hides it. So from here till here it is 200 mm, and from here to here it is 100. So 100, 200. So every 5 is 500 mm. Sorry, 50 mm. 1, 2, 3, 4, 5. This is 50 mm. So 50, 50, 50, 50. So that is 200. So yeah, let me bring the scale back. And I can make this tool available for someone who asks for it in the messages. You can just put a I want this model. Yeah, I can send you the link. Yeah, I used that as a reference, and then what else? I brought in 2 cylinders, which is the next thing. For this case, it requires so once that is there, I'm gonna switch that off, and okay, so yeah, that there. So okay, nothing fancy, just a cylinder with no caps. And I also made sure I reduced the number of divisions to 12, so I know it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 points all over. the circumference, and not many lateral splits. So I just reduce the divisions in Y and Z as well. And this one works as a reference here. So let's say I wanted to create a tube, and there's a new tube. And if you have the snap on with vertices, and typically I don't add okay, the way I drew here, I typically don't do. Reason why is it changes the axis, center axis. So I typically go here, add tube, and that goes directly to the center, and make sure use the gizmo and then move to the point where I want it to be. I want the center to be, and then start adjusting those the points. So from here, then I'll go snap it here, snap it here. Just quickly snap all the sides. Yeah, too many trials, so there are many files which I had to hide just to show you. Okay, and I'll hide that one as well so that I can show this tube here. What I have done here is, if I bring back the scale, you can see what was the dimension I was planning. So center to center of these two circles, I have planned somewhere around 200 mm. That's what my aim was. And let me see what was the dimension I got. Is the scale up to 200 now? 50, 150. So the width I planned for 100 mm, so it is somewhere around 97. But I planned for it, but I reduced eventually because I wanted it to be wider on the outermost edge, which is this hexagonal. It is like a small cap which projects on both the sides. So since that was the aim, let me see if I can measure from here. Vertices, yeah, vertices. Yeah, it does allow us to measure. Yeah, 198, close to 200 mm. That's what the plan was. And I created two cylinders, and use the tube tool. Just quickly grab the tube tool, adjust the points now, snap it here, towards the outer edges. Let me hide that, and made it as a closed loop. Once it is closed towards the edges, I can quickly snap it to the vertex. And it's so easy to snap these. And since I know there are 12 number of vertices around the cylinder, only 1, 2, 3, 4, 5, 6, 7 if I just snap these 7 points, I would already have, with B spline on, it should be perfectly smooth curve, and that's what I want here. And in this axis it shouldn't be there. I think there are 2 cylinders there, and that's why it's getting confused. Yeah, perfect. There, 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 and there. So now this is gonna be tangential, and even with the tangent, you can see it is still away from this line, which I don't want. It should be tangent after the, like, until this point. So what I do is I make those hard points. Sometimes if I don't want that to be hard point, I can go make a hard point after that, somewhere here. Or if I want it to be so crisp, maybe I go closer and make it a hard point there. I do the same on all the edges, hard point. Maybe 2 hard points there and here as well. So that gives just a tube, and like, since I snap to the cylinder, it is going to be perfectly aligned in this axis as well. All the points are. And now you have all the freedom to adjust the profile. For this case, I typically don't use the scale. What I mean by scale is this radius here. Let's say I adjust this, it enlarges all the sides. I don't want that. So what I usually do is go here, find which direction what point is moving, and I'm gonna pin this so that it doesn't move. So I know this, when I move this direction, it goes here. So I'll keep that as an idea. Move this, move further. And if you see, there is a pink line, and that snaps to the straight line, the same line. And I typically make sure I don't have to have the headache of adjusting the point, so snap it 2 visible lines there, and that's it. Now I know this is 1 unit square for this profile window, and I'm gonna quickly verify what is that dimension, and that defines this 1 unit for the grid as well. So it is in scale. So since I already scaled the grid for my tool, I know each division is 1 mm here. So that is, this is 10 mm, 20, 30, 40, 50, right? So if I know that each division is actually 1 mm, and the thickness which I have here is actually 1 mm, and what is the thickness I want, that is what is going to be the thickness of. So if I want 1 mm thickness as a wall, that's what I'm going to define here. So this is for 1 mm, so if I want 2 mm, I just need to move it up a bit. So it's going to be now 2 mm thickness. And if that is 2, what is the width now? So it is 100. So this is 200, and this is 200. which is 20 mm, I think, right? Yeah, 20 mm. Sorry, did I say 200? It is 20 mm. So 1 mm, 1 mm, 1. So 10, 20 mm. That's what it is. So you can see there as well in the profile what I mean by 20. So each one box is 1 mm, and I have covered 20 all over. If I go and show it in a bigger view, you might understand. So there are 20 boxes I have covered, and that is 20 mm. And if I want, for this case, I have 100 mm, right? So yeah, 20, 30, 40, 50, 60, 70, 80, 90, and that's going to be 100. The pink line, yeah, that's a 100 mm line, wide object. And you can see in the grid as well, it is 100 mm wide. It is to scale, and once this is designed, now if you see in the wireframe mode, since so if I this is what defines the total number of the quality of the mesh itself. So if I go in solo mode, what I mean by that is, let me change the grid wireframe color, be slightly brighter, yeah, it might be even darker. Okay, so where was I? Yeah, the quality of the mesh. So for the quality of the mesh, if you see, this defines the quality of the number of divisions. If I go too high, it's going to be too much of too much of triangles. Typically people think too many number of triangles is going to give you so smooth, so much of smoothness in your 3D print. You see how smooth this is here. And if I show the object, the final model what I had, it doesn't has that much that many number of triangles. It was oh, this is, but since I adjusted the quality in Bamboo Lab, I was able to get I made sure it print, yeah, I left it printed for a while by changing the layer height, and that's how I got this smooth surface finish for this. So yeah, I did add more profiles, not too much as some people say. So in this case, let's say I would go somewhere around. Definitely, I want more divisions on the Y, at least 300 or 400, let's say. That should give you smooth enough. And if you go and if you remove the smooth shading, and you can see in the face group view, yeah, the layer lines are gonna be visible here, but actually when you print it, it doesn't. So if you want, okay, if you are so worried about layer the smoothness of your 3D print, you can go further until you don't see any seam lines in this view. It is so smooth. But the challenge here is the file size is going to increase. In this case, there is we don't want to go beyond 100K, and so we can reduce this definitely. Might be go even further here, but you can increase this one higher. So this gives a smooth surface overall, and your number of triangles is already 30K. That's it. You're still having a smooth surface, and number of vertices also under, yeah, 330K should be far enough smooth. Okay, this is just object, and I didn't just leave it at that point. So what I wanted was actually increase the thickness. If I go in wireframe mode, yeah. So I made this profile. It's the same technique. I just made this profile, added a small groove towards the end on both the ends. Yeah, I could have made it symmetric to x-axis or whatever axis, and I could have done it only one side, but yeah, this is how I tried it. A groove for one side, and I thought of leaving it as it is, but then I thought, what if I fill that groove with something? And that's when I copied the same tube, and used. So let's say what I copy this, I clone it. I'm going it in solo mode. I just cloned it and went in profile, and what I did was remove the closed option, so I know it is going to be open in one of the junctions, and removed all other points, and here, and it made it closed. Now it's going to be closed. So why I did that was, since I used the same tube tool, if you see, it is going to be there exactly on that same spot. It overlays on the same location, and I need not worry about the fitment at all in this case. So I just need to now worry about how much tolerance I want between these two. This is a separate object, this is a separate object. If I want it to be within the same body, I can have it, but if I want it to be a separate object, it's already within the design. Let's say I wanted to, this is like a parametric model, I can adjust it, and it adjusts along, it can be modified as you want. So now that I know it is going to be on the same location, I just need to worry about how much tolerance I need to give all over the body. So what I'll go is profile, go there. Let's say I want, so I know 1, 2, so it is a 10 mm square. So 0.1 per side is what I would typically give. So I just need to change it there. It is 1 mm, so 0.1 mm. 1 mm, 0.1 mm. 1 mm, 0.1 mm. And here as well, 1 mm, 0.1 mm. So if I now go there and see that, you have created a 0.1 mm clearance between both the bodies. That means you can confidently say it is going to fit once you 3D print it. And if you struggle, okay, let's say you printed it and this tolerance was not enough, you can go edit it again, go edit profile, go there, and yeah, maybe add another 0.5 or 0.05 mm. You can zoom in and adjust, and this gives full control over the dimensions of the bodies, and that means you can get actual tolerance closer to a CAD design software. So that's how I created, so I'm going to delete that because I already have it there. Remove the solo mode, that's how I created this body here. Removing the wireframe mode, and this here I could have done it as a box, but For some reason I wanted to have an option to create a hole within it as I designed. So in a solo mode, this box is not a regular box, it's just a cylinder. If you see it, doesn't look like a cylinder, obviously, because the number of divisions is 4, and then I haven't given it linear subdivisions by 5, and it automatically gives you a, okay, I actually add a one more on this post subdivision as 6, so that you can get a smooth transition over the sharp corners, and which you can see here as well. As you print, I hope you're able to see here, there are sharp, like it goes sharp and then it gives a smooth blend towards the edge. And since I already subdivided with 5, it's already close to a sharp corner, and let's say if I remove that sixth post division, it's not going to have that smooth corner transition there. That's it. And it gives a subtle quality look for the 3D prints. Yeah, that was so good. I need to just create a cavity for this to enter the main body. And what I did was, so since I know this, so why I used a cylinder is I know that I can control the dimension by just straight away typing in the value what I want for the hole and the outer dimension, and I know that is gonna define the thickness, wall thickness. So once I know that is there, let me clone it and I'll show you what. Oh, clone gives you an instant. Clone an instance. Delete it. Delete this. And I'll move this up. Come on. Okay. To go in solo mode, what I did was just validate it. Now you know the face groups are there. You can use the hide option. Hide this, this, and this. You know that is hidden. And you can delete it. Delete the hidden face groups. And so even before doing this validation, so I want to create a cavity on the main body, so I wanted to give a tolerance around. So for that I would give, let's say I want a 0.1 tolerance for the cavity, so just 727.2 1 nano per side. So it's gonna enlarge the whole object. Just validate it and then hide these bodies, these faces, and delete it. Now it is just a box. You can use the mask menu to close the holes. Now it is a solid. You can have it hidden, and now from the main body, if you subtract it, let's say, yeah, I need to make sure it doesn't enter in. So I could, I will have to adjust the height. Where is the grid? Okay, grid, just somewhere around here, and do the same process. Hide this, this, and this, delete, close holes. So now if I hide that and from here boolean, it's just gonna create a crisp cut over the body, and now if I go unhide it, the previous cylinder is gonna smoothly align along with it. So that's how I got this. So the gray is the main body, main tube, and the pinks are individual parts which I made using the tube, individual cylinders, and I gave a tight tolerance. Yeah, these are separate pieces actually. We just need to insert it. It just goes in smooth. and that's how I gave the tolerance there. Is a let me measure it. So for the width, it was 30 mm, 30.5. That's what we have here. And if I see the same width, .4 and 30.4. Oh, just close. So 30.6 actually here, and 30.4. So per side 0.1 mm I gave the clearance, and this was, so if you see the top edge is a separate cylinder and the bottom is a separate cylinder, both combined together, that is one body with 0.1 clearance on all the sides, and it just goes in. So now the add body is done, and this one was the same cylinder. So if you see the hexagonal pattern, that is same. I just need to use the same tube tool as I created the center ring. I just need to, let's say, have this tube here, and I validate it. It gives you, it doesn't separates the phase groups. So you can use the phase group, go in normal, it just uses the normal direction to separate all the phase groups, and I can quickly go hide yeah, this and this, and delete those. Now if you go to the mask menu, close the holes, that's it. So if you had a, if you would have had a thinner body, so you could have reduced the thickness, and that's how you can create those caps as well. So that's how the cap was done, and now I will show you how I did it. So what I did was exported all the files as STL for this case. I could have sent them as GL OBJ, but I selected STL, selected only the selected items, which is this, selected these, exported it, and saved it in my OneDrive. And I'll show you how it looks in Bamboo Lab. Okay, hope you're able to see this. So I brought it in Bamboo Lab, and you can see those parts, individual parts. I wanted it to be a separate part because this here was printed using PLA glow. It glows in dark, and I can show you. Yeah, it glows in and I had it on both the sides. I embedded one along with the body, and that's what you see it here. The main body tube has one, and it printed for a while, and it shouldn't have that much big of a prime tower because it was a thin layer anyway. For some reason it is showing like that. Yeah, let's see what does it show after. It shouldn't show a big prime tower. Takes some time. Oh yeah, so that is where the quality comes in. So I chose the point 2 mm standard. In this case, actually I chose the best quality when I actually printed it. So I went up to 0.2 mm high quality, I remember. So that took a while to print. This is a 5 hour, right? That one was longer print. And you can see, yeah, as I said, the prime tower is small, and it did create some automatic trees for the support. I chose this side uh, as the bottom face because I didn't want a larger prime tower, and I wanted a smooth surface finish on this face. And about the hexagonal pattern, so that one you would have seen in many videos that you can remove the top surface and the bottom surface of a 3D print, 3D printing body, and in an object mode. If you uh, let me slice it and see, yeah, does it show? Yeah, so you can see it creates a hexagonal pattern, which is the infill it's by itself, and that is where here it is for the object. uh, yeah, here captured or strength, you can see the wall loop is 9. I have removed the top layer to 0, bottom layer to 0, and the infill is honeycomb, and the density is 20, which gave uh, yeah, which gave this quality. Did I even show? Okay, I think I missed. Yeah, it was for the hexagonal pattern.